and welcome to the ACHEMA Pulse Webcast. With ACHEMA Pulse only 6 weeks away, we are once more focusing on the trends that shape and change the process industries. And you can join us. Just go to Slido, put in the hashtag ACHEMA Pulse, and ask your questions, bring your comments to our discussion here in the studio, and we'll take it right to this table. Now, one of the trends that currently literally everybody's talking about is hydrogen. Whether in Germany, in Europe, in North Africa or China, hydrogen seems to be everywhere. And the visions are really large. We're talking about hydrogen economies, about covering all our needs with hydrogen, be it energy, mobility, industrial requirements, such as for the steel industry, or the production of chemicals. But with all these big visions ahead, well, some of you might be wondering, just as I am, how do we get there? And how do we even start? This is what I will be discussing with our guest today, and I'm very happy to have him here. He's a full professor at Leuven University in Belgium, where he teaches techno-economical aspects of the power system and is the vice president of the Leuven Energy Institute. He's also the founder and CEO of Energy World. This is a research collaboration on energy in smart cities and smart buildings. And on a larger scale, he's the executive director of the Global Smart Grids Federation. So welcome, Professor Ronnie Belmans.
Thank you. Glad to be there. Yeah, there, wherever there is these days.
Yeah, great to have you with us today and to learn something from you about hydrogen, how we will get there. So the future from all those visions and strategies seems to be set out, but how do we get there? Can you give us an introduction in a couple of minutes about, well, all these visions and the aspects that we need to cover?
Yes, Catherine, I will try to do so. It's quite a challenging task to do so in a few minutes, but let's be fair and clear from the beginning. And the beginning is, do we need hydrogen? And the answer is yes, but it will be different than most people are thinking these days. And I will call it electrons and molecules to feed the economy, because that's important. Where are we? What are we doing? At this moment, fossil fuels drive the world. And I've taken here from Eurostat the energy, the fuels coming from imports coming into Europe, the EU 27. And you see oil and petroleum is dominating the whole system. Gas has a quarter, and the rest is, let's say, not too much. What you miss here on the picture is nuclear, because nuclear is not an energy import, it's so-called material import. Hydrogen is nothing new. Hydrogen is used massively in the industry, in the chemical industry. And who am I talking to? I'm talking to the specialists on that, so I have to be very careful here. It's used in refining, iron and steel, and in general industry. And at this very moment, there is already a massive use of hydrogen in the world, in that industrial world. Whether it will all be there by 2050, let's be very careful, because what will be the situation of refining by 2050 if we go out of fossil fuels, which is the target of the European Commission? And if we look at the European Commission as such, very important is the so-called Communication 299, Powering a Climate Neutral Economy, a strategy for energy system integration. And I'm an engineer, proud to be so, and we want to go for a renewable and sustainable energy system. So the Commission says, rightly, a more circular energy system with energy efficiency first. Then to accelerate electrification of energy demand, building on largely based power, renewables-based power system. And last but not least, if 1 and 2 don't work, if you can't electrify, which also brings energy efficiency, and you can't make it circle with energy efficiency, then go for sustainable fuels, low carbon fuels, including hydrogen. So it's not that hydrogen has no place, But hydrogen has a place with respect to the future where the electrification doesn't work, because electrification is always more efficient. How much hydrogen will we need? And I can point you already to a paper that will come out next week with the Florence School of Regulation, where I'm also working. There will be things which are hard to electrify. For instance, shipping and aviation. We use at this moment 1,000 terawatt hours of liquid fuel for shipping and aviation. That will be done by fuels in the future. We will need it for storage, for this so-called very nice German word Dunkelflaute, 1 week without sun or wind, but even more. If we are going to import hydrogen and synthetic fuels from Morocco, from Australia, from Chile, from Saudi Arabia, we need strategic storage. And we made a calculation for industry, and we looked at Eurostat. At this moment, industry in EU27 is using 1,560 terawatt hours of fossil fuels. And low temperature heating will be done by electrification, but we will need fossil fuels to be replaced by synthetic fuels, by hydrogen, probably uh, probably connected to CO2 to produce, for instance, ethanol, methanol, methane, and also ammonia. So in industry, the overall demand will be really going to those synthetic fuels, amongst them hydrogen. And if you look at what Agora, well known to you, has been saying over the last weeks, you see a almost constant demand for hydrogen, which is going to be shifted from refinery applications a lot to steel. So there will be a massive need for hydrogen-based synthetic fuels, probably most of it imported to Europe, because we will need all of the renewable electricity for serving all the electrified solutions. And with that massive import, we will see hydrogen coming in disguised as methanol, ethanol, also synthetic kerosene or diesel, and ammonia, and also maybe pure hydrogen. So it will be a very nice intermixed, interleaved system integrated with a lot of electricity used here and molecules coming in to serve whatever society needs. And then we come to a very nice map. And here you see what Agora said as a no regret hydrogen network, which is North Rhine-Westphalia, Holland, Belgium, where there is a massive use of hydrogen already now. And whether there will be a real hydrogen backbone, that might be doubtful. But time will tell. So we will need it, it will come in, and we will use it at those places where it is best used. So that's what I wanted to say. It may be a bit not the, how should I say, the straightforward way that we are going to do whatever can be done with hydrogen. Everything can be done with hydrogen, but not in the best way. So use it where we should use it.
Okay, thank you very much. It was a very, very comprehensive overview, and you already put some of the hydrogen visions into perspective. I encourage our viewers to ask you questions via Slido. We have the first questions coming in, so join our other audience members who are asking and commenting, and we'll pass it on in a second. But first, my first question, that's the privilege of the chair here. Everybody's talking about hydrogen, and we have already experienced other technologies where everybody said, well, we will do everything by using biomass or do everything by using whatever. So is hydrogen really such a big solution, or is it just another hype?
It's neither of those. It's not the solution. It's not the silver bullet. When I was young, we had cowboy movies on television with John Wayne, who was killing with one silver bullet 5 Indians. This is not what is going to happen. It will be part of the solution. It will be not a big part in energy. It will be the basis of a lot of other chemical stuff which is coming in and will be, for instance, used as synthetic fuels. Hydrogen will not be used, should not be used, for instance, for cars because it's inefficient. It should not be used for heating homes because it's not efficient. We should use it because it takes more electricity than just using electricity for doing the same purpose. But it will be needed as basis for synthetic fuels, and it will be needed also as feedstock for instance, steel making, for chemical plants, but it will not be the overall overwhelming replacement of all petroleum which is now there.
But still, I mean, even I said you put it into perspective by pointing out the role of efficiency, energy efficiency, the role of electrification. Still, we will need a lot of hydrogen. So where is that going to come from?
If we made an analysis on the amount of renewable electricity that we can make around Europe, okay? And if we look at that amount of electricity, this is almost insufficient for doing everything that we need to electrify. So we need to find those electrons to produce that synthetic fuels somewhere else. Mm-hmm. And places are North Africa, places are Arabia, Saudi Arabia, and that Oman, that kind of stuff. There's a lot of wind and sun in Chile. There's a lot of wind and sun in Australia. So there are a lot of suppliers where we can have very low cost PV and wind, and then transport it as a market, like we do with petroleum, like we do with natural gas, to Europe to use it. So that will be the normal, if you go engineering and do it the most efficient way, which is also the less costly way, that will be the case. Use the electricity that we can harvest here as electricity here, and bring those molecules in from outside the EU.
I think that's already one important aspect that we haven't maybe stressed so far before. We need green hydrogen, right? We can't use the hydrogen we're using today because a lot of it is not green, it's not produced renewably.
It's what we call gray hydrogen or even black. If we look at Australia at this moment, they're producing hydrogen from coal. So this is the worst you can get. Of course, we can have a transition because it's an energy transition. In the end, by 2050, it should all be green. But if we want to reduce the CO2 already faster, we can use carbon capture and storage to take away part of the hydrogen, 90%. Okay, and use 1, 2, 3 decades, for 25 years already the blue, and then go as electrification go on and as the new routes to get to hydrogen farther away become to green, gently move to the green. So it will be a fading in, fading out. Also, there is what is called the turquoise hydrogen, which is the pyrolysis process where you use far less electricity and you get carbon black out of it. So there are different routes. There is not one silver bullet. Even within hydrogen, there is not a single bullet. So blue can be a transition. Blue can be a picking up of CO2 faster than before. Whatever happens to pyrolysis, it uses less electricity. So maybe it can be done in Europe because it uses less electricity. And then if you go full green, certainly we cannot do it here.
What is the biggest hurdle in scaling up the production volumes of hydrogen? Is it the availability of renewable energy, or is it the size of the electrolyzers? Which should be tackled first?
You can only solve the problem if you have all the pieces of the puzzle. Okay, the increasing size of electrolyzers is something we need to do. If you need it, we will not do with 10 megawatt electrolyzers. We will not put 1 gigawatt electrolyzer installations. This will not be done. We need bigger units. We need a lot of renewable energy, but this is really going quite fast. If you see to the last installations which are now tendered, then we get to prices of $1 per kilowatt hour of PV installations. So this is going to be massively and maybe very extremely fast. But it will be step by step. The market will develop, but we should really, from my point of view, the most important thing is to have the intake installations in Europe ready, which will be the harbors, like going from Hamburg over Rotterdam to Antwerp, to make that ready, that Europe can really, as we are doing with LNG, with liquefied natural gas, that we can have the same type of intake of those molecules, being it hydrogen, being it ammonia, being it that's of course methane that we are used to. So how do we get those to substitute the petroleum that we get in by those smaller new synthetic molecules?
Now, you pointed out already on the map that we need more infrastructure than just generation, also pipelines or something, not only for hydrogen, but also for carbon dioxide, which we also need if we want to produce chemicals. How much effort will it take? How large is the investment to set up this infrastructure?
It will be a step by step. We made a study together with the ACHEMA and TNO in Holland and Energyville. We made a study for ammonia, and you can find it. I can provide it to you. You can make a link on your website, and that's a cost which is relatively modest. It's a pipeline that would go from Rotterdam to Antwerp to Geleen and then further to North Rhine-Westphalia. So these are things which are doable, but we need them all in parallel. So we cannot. The good thing about petroleum is that it contains everything. Okay, you put petroleum in, you get everything out. Now we're getting rather pure molecules in, which means that we have smaller parallel pipelines. And that's going to happen. And I see now in Belgium, they are trying to bring a pipeline system, 3-4 pipelines in parallel. So they will be different, and that will cost, but it has to be done as soon as possible.
Will we really be transporting hydrogen, or will we use some other molecules like liquid organic hydrogen carriers or something?
Hydrogen is a hell to transport by ship. Okay, you need it in a liquid shape, and it only gets liquids by minus 253 degrees. So if you want to liquefy hydrogen, you lose 30% of its energy content. Okay, that's horrifying, and it's also quite difficult. So we probably, if we can use, for instance, if you need ammonia for making fertilizers, why should you bring hydrogen in? Produce ammonia immediately where you produce hydrogen and put ammonia on the ship. If you need ethanol, if you need methanol, take CO2 out of combustion here, bring it to Morocco, and mix it together with the hydrogen to get methanol and bring the methanol over here. So shipping hydrogen as such will be difficult. Disguising hydrogen, as you say, in liquid storage, liquefied storage systems, or as other molecules, will be done. So it will be disguised.
But this also means we're going to change the whole, chemical world, so to say, because we are going to produce basic chemicals where the hydrogen is, and not necessarily here in Europe.
It will be different. You will get rather pure molecules, small molecules in, and maybe you will get kerosene in and diesel in, but that's for those harder to abate transports like aviation and shipping. But it will not be the bulk petroleum that is coming in and that has to be refined here to get the small molecules out, which are then used in chemistry.
So you pointed out already that hydrogen is not the solution for everything, and there are some better ways to cover other needs. So how does hydrogen combine? What is another trend, like maybe biomass or other things, chemical recycling? What fits together with hydrogen nicely?
If we have been studying the the biomass. If you look at biomass, we have to be very careful because growing really crops to make biofuels is not the best way to go. So biofuels can add, and again, no silver bullet. One of the bullets we are going to use, if I don't like the word bullets because it's so destructing, one of the elements of the puzzle we're going to use is for 5, 6, 7% going to bio. But again, we have to be very careful. If I look at chemistry and the added value you can get out of a biofuel, either as a fuel to burn or a fuel to give molecules to bring the carbon to the chemistry, the added value in chemistry is massively higher than just by burning it. Mm-hmm. So you can use, whether you better not use it directly to burn it, but produce bioplastics which you can recycle, and after a while, if they're not recyclable anymore, then finally burn them, pick up the CO2 and reuse it again. So having that circularity always in front of you is important. And we need carbon. It's not I hate the word decarbonization. It's carbon neutrality. Because if we would not have carbon, we would not be talking, you and me, together now.
Yeah, that's true. For a chemist, decarbonization is kind of counterintuitive.
Also for steel makers.
Yeah. Well, Professor Belmans, this was a short introduction into hydrogen, but I think you opened up a whole world of aspects and things to discuss. So thank you very much for giving this teaser today. And we're really looking forward to seeing you again at ACHEMA Pulse, where we have much more time to talk and dig deeper. So thanks for today.
Be here. Have a nice weekend and see you soon.
Same to you. Thank you.
Bye.
Bye. And for our audience, I'm sure that you have been inspired to have more questions, to dig deeper into the topic of the hydrogen economy. And don't worry, it will be a big topic at ACHEMA Pulse, not only in our highlight session with Professor Belmans and other experts, but also throughout the program on 15th and 16th of June. So make sure to register, get your ticket, have a look at the program. It's already on the website, and prepare your schedule to learn all there is to know about hydrogen and about other things as well, of course. Our next webcast will be next week, next Friday, and then we will be talking about artificial intelligence in the process industries, another big trend that is really having a big impact on how we produce, how we work, how we